Today we're going to be solving some absolute value equations. These can be a little tricky, but I have some steps that's going to help us with all of these. We have these two. We're going to do two more after this. The steps that are going to help are to isolate the absolute value bars. I'll show you what that means here in a second. And then we're going to make our two cases, both a positive and a negative case, as well as we have to solve both the positive and negative case separately. So let's look at this first one. Is our absolute value bars isolated? What isolated means is it the only thing on that side of the equal sign. Well, if this is my equal sign right here, I also have a +3. That can't be there. That has to move to the other side. So of course, we're going to move that over by subtracting 3. Right now, I have the absolute value of x equals 8 minus 3 is 5. So now, is it isolated? Yes, I'll put a little check mark there. Okay, now we're going to make our two cases. When we do this, you have to do something that a lot of people forget, and that is we're going to drop the absolute value bars. So instead of saying the absolute value of x equals 5, I'm just going to say x equals 5. All right, that's my positive case because it's a positive 5. The other one, I'm going to make the solution a negative. I'm going to say x equals a negative 5. Okay, so I've made both my cases. Now it says solve both separately. Well, in this case, my x is already by itself. That's what we solve for. We're solving for x. And so you can say that the answer to this question is both a positive and a negative 5. For the next one, it's going to be a little bit more complicated in there. So let's see if we can try this. Let me erase my checklist here. Isolate. Is this isolated? Well, if this is my equal sign, is there anything outside of those absolute value bars? Yes, there is. There's a negative 4. And it's being multiplied, since it's right next to those absolute value bars, we have to divide. One thing you cannot do, you never ever can distribute into your absolute value bars. They are not parentheses. You have to get rid of this by division. Okay, so let's divide by negative 4. Now we have the absolute value of 2x plus 1, okay, equals, and then negative divided by negative is a positive. 36 divided by 4 is 9, just like that. Okay, is it isolated now? Yes, it is. I can put a check mark there. Next, I'm going to make my two cases, both a positive and a negative case. So again, I like to kind of draw arrows to help remind me. My positive case, I drop the absolute value bars. So it's just 2x plus 1 equals a positive 9. That's my positive case. And then the other side, 2x plus 1 equals a negative 9. All right, so both of those are good. And now I'm going to solve them both separately. You can do this sort of together, or like what I mean by that is at the same time. For example, in both cases, we're going to be subtracting 1. So you could do that at both at the same time, or you can do one separately and then the other. It doesn't really matter a whole lot. But you're going to have two separate answers is what I mean. 9 minus 1 is 8. So if I divide by 2, here x is going to be 4. Now on the other one, if I move this over, that's going to cancel. 2x equals a negative 10. And so if I divide by 2 on both sides here, x equals negative 5. So the two answers for this problem are going to be 4 and negative 5. Let's try two more, including one with no solution. All right, I got two more for you here. This first one says negative 2 times the absolute value of negative 5x minus 7 minus 2 equals a negative 66. So we're going to go back to our checklist. Isolate our absolute values and everything inside of it, which I have is negative 2 on the outside and this negative 2. And so I have to move both those over. Now, this one's being multiplied, right? You can, since it's being right next to the absolute value bars, this one is subtraction. When we undo things, we have to move that subtraction first. So I'm going to add 2 to both sides here. And that's going to give me now negative 2 times the absolute value of negative 5x minus 7 equals a negative 66 plus 2 gets me back to negative 64. All right. Just like before, we have to move this negative 2 on the outside by dividing it. We cannot distribute in. Okay, and that's going to be good because now it gives me a positive over here, a positive 32. So I have negative, the absolute value of negative 5x minus 7 equals positive 32. So finally, my absolute value bars are isolated. There's nothing on the outside of those on that side of the equal sign. Next, I'm going to make my two cases, both a positive and a negative case. I like to draw arrows. You don't necessarily have to. We have negative 5x minus 7 equals 32. What you do have to do, though, minus 7 equals negative 32. What you do have to do is drop your absolute value bars. Once you split it, that's what I always kind of like to, if I make a mistake, I like to go back and see, Was there somewhere where I knew that my mistake happened? By drawing these arrows, I know that anywhere after that, I shouldn't have those absolute value bars anymore. So that's why I draw the arrows. All right, anyway, our two cases are made, positive and negative, positive 32, negative 32. Then we're gonna solve both these separately. All right, so let me do this real quick for you. Okay, a couple things with this. One, sometimes you're gonna have problems that don't turn out very nice. And depending on what your teacher asks for, you can either leave it as a fraction, like I like to leave it as, negative 39/5, or if they have you type that in your calculator, you could get that to be negative 7.8 or whatever it is. That said, one thing with that is sometimes I'll have students ask, well, why is the negative there? Why is it in the front? Or why does it almost look like it's negative 39 over 5 and where over here is 39 over negative 5? It doesn't matter, all right? If you think is a positive divided by a negative, that's a negative, or a negative divided by a positive, which is also a negative, what you can't have is a negative over a negative because that's a positive. So be really careful that I like to just leave it kind of out front so I don't confuse those two things. The whole thing, this fraction is a number, right? This fraction is negative. All right, let's go to this last one here. I promised you something earlier. If you remember that, you're gonna maybe be able to see what's gonna happen on this one. But let's start by subtracting 8. And we're gonna have negative 8 times the absolute value of negative, or times x minus 9 equals 96. Okay, and then if I divide by negative 8, we have x minus 9, I believe that's 12, equals a negative 12. And this is no solution. Why? Absolute value itself implies distance. And here, distance says equals something that's negative. Distance can't be negative. If I were to throw my car in reverse and drive backwards to my house, I didn't go a negative distance, I just went backwards, all right? Distance has to always be positive. So you're basically saying distance is something that's not. And so therefore this is no solution. So you can write no solution or no real numbers, whatever your teacher has you do for that one.